Hello, here's the video solutions for section 12.5. So we'll start with number 9 on page 824. So it says the line through the points -8, 1, 4, and 3, -2, 4. So we're going to try to find parametric equations and symmetric equations. Remember in class I mentioned that symmetric equations were not something I wanted to emphasize, but I will show you the solution just in case you're interested. So the direction vector v is going to be found by taking one point minus the other. So I'm going to take 3 minus -8 for 11, -2 minus 1 for -3, and 4 minus 4 for 0. So that's our direction vector. Our position vector is any one of the points. I'm going to go with -8, 1, 4. And then since they want us to do this parametrically, I'm going to first write it in vector form just because I want you to get used to seeing it this way. Then we'll turn it into parametric. So we start at the point -8, 1, 4, and we're going to add scalar multiples of 11, -3, 0. So parametrically, of course, it would just be x equals -8 plus 11t, y equals 1 minus 3t, and z equals 4. So if you solve each of those for t, for symmetric equations, you'd have x plus 8 over 11 equals y minus 1 over -3, and then z equals 4. So that's one of those cases where you can't actually make an equation with 3 parts because the last component doesn't have any coefficient in front of t. All right, for number 10, we're going to find the line through 2, 1, 0 and perpendicular to both I plus j and j plus k. Okay, so if the line is perpendicular to both of those, its direction vector is going to be the cross product of those two vectors. So let's take the cross product of those two vectors, which is 1, 1, 0 and 0, 1, 1. Okay, so we'll do I, 1, 0, j, 1, 1. Okay, so first we are going to do the sums. Got to get this right. These are going to be the positive sums. So it would be I plus k minus, now we'll do in blue the negative sums, minus j, and that's it, right? Yeah. Okay, so it's the vector 1, -1, 1, and let's go and confirm that on the calculators to be sure. So menu, matrix vector, letter C for vector, cross product. We're going to create a 3 by 1, and it is the vector 1, 1, 0, and 0, 1, 1. We get the vector 1, -1, 1. Great. Okay, so that's the direction vector for my line. Okay, so if we want to do this parametrically, it would be x equals 2 plus t, y equals 1 minus t, and z equals t. Remember, the coefficients of t are coming from the direction vector. These are the coefficients of t. So to solve these each for t, it would be x minus 2 equals y minus 1 over -1 equals z. So that would be symmetric equations. Okay, next is 20. Problem says, determine whether the lines L1 and L2 are parallel, skew, or intersecting. If they intersect, find the point of intersection. L1 is given as x equals 5 minus 12t, y equals 3 plus 9t, z equals 1 minus 3t. And L2, x equals 3 plus 8s, y equals -6s, and z equals 7 plus 2s. Let's look at the direction vectors to determine if they're parallel or not. So this direction vector is -12, 9, -3. The other direction vector is 8, -6, 2. Let's see, is the ratio of each of those -3 halves? It is there, it is there, it is there. Yes, so these are actually parallel lines. So no intersection. If they were going to intersect, what we would do is we would set, say, this equal to this, and this equal to this, this equal to this, and then we would solve the system for s and t, and that would get us our point of intersection. Okay, next we have 24. All right, find the equation of the plane through the point 5, 3, 5, and with normal vector 2, 1, negative 1. All right, this is A, B, and C. Okay, so we've got 2 times x minus 5 plus 1 times y minus 3 minus 1 times z minus 5 equals 0. That's our equation. Real nice and easy to set that one up. Next, we've got 30. Okay, the plane that contains the line x equals 1 plus t, y equals 2 minus t, z equals 4 minus 3t, and is parallel to the plane 5x plus 2y. Okay, so parallel to 5x plus 2y plus z equals 1. So the normal vector here is 5, 2, 1, which means our normal vector will also be 5, 2, 1. But if it contains the line that's given, that means it also contains the point 1, 2, 4. So let's construct a plane with this normal vector containing that point, and we'll have it. So 5 times x minus 1 plus 2 times y minus 2 plus 1 times z minus 4 equals 0. That's the equation of our plane. 31. The plane through the points 0, 1, 1, 1, 0, 1, and 1, 1, 0. Let's make two vectors. I'm going to make vector u, which is going to be this point minus this point. So second point minus first point. So 1, negative 1, 0. And let's make vector v, which is the third point minus the first point. So 1, 0, negative 1. We'll take the cross product of those two. So u cross v. Remember, you can do v cross u if you want. It doesn't matter. We're just interested in direction. We're not interested in the we're interested in whether it's, kind of the general direction of the vector, not whether it's pointing up or down. So I vector times 1 minus j vector times negative 1 plus k vector times 0 minus negative 1 or 1. So we've got 1, 1, 1. Okay, so if that's our ABC, that's our normal vector, we'll use one of the given points. I'm going to use the first point. So we'd have 1 times x minus 0 plus 1 times y minus 1 plus 1 times z minus 1. I'm just going to clean that up a little bit. So we've got x plus y minus 1 plus z minus 1 equals 0, or x plus y plus z equals 2. And you can always confirm that that plane does contain those points just by trying them, and they do. And our last problem is 58. Okay, so find parametric equations for the line of intersection of the planes. 3x minus 2y plus z equals 1, and 2x plus y minus 3z equals 3. So we talked about this in class, and one way to find the direction vector for the line is to take the cross product of the two normal vectors. So the first normal vector is 3, negative 2, 1, and the second normal vector is 2, 1, negative 3. I'm just going to do cross product of that on the calculator just to save a little time. Okay, so 3, negative 2, 1, and 2, 1, negative 3, 5, 11, 7. So the direction vector for this line is 5, 11, 7. Now we're going to try and find a point on the line, which means we're going to try and find a point that's on both of the planes. I'm going to do that technique of letting z equals 0, giving me 3x minus 2y equals 1, and 2x plus y equals 3. Multiply the second equation by 2, so 3x minus 2y equals 1, and 4x plus 2y equals 6. Adding down gives us 7x equals 7, or x equals 1. So if x equals 1, we've got negative 2y equals 1 minus 3, which is negative 2, so y equals 1. So the point would be 1, 1, 0. All right, so what did they want? Parametric equations? They do. So x equals 1 plus 5t, y equals 1 plus 11t, and z equals 7t. And then find the angle between the planes. That's going to be the angle between the two normal vectors. So we can say cosine of theta is n1 dot n2 over magnitude of n1 and magnitude of n2. So n1 dot n2, let's do that here. 6 minus 2 is 4, minus 3 is 1. Magnitude of n1 is root 9 plus 4 plus 1, so root 14. And magnitude of n2 is same deal, root 14. Oops. Root 14. So we've got inverse cosine of 1 over 14. 85.9 degrees. All right. Let me know if I made any mistakes. I think it looks good. And remember to please submit this on Google Classroom so I can see your work.